Okay. Okay. And this is sort of a, let's say, a restriction now on the first counting rule, that we start off with k objects, okay, and if I select the first object but don't put it back in the bag, well then for the second selection we have a different number of objects than we had for the first selection. Actually, in that case it's reduced by 1. Okay, so we start off with 5 objects, okay, and if I select an object, well, the number of possible outcomes for the first selection is 5. But I don't put the first object back in, so the number of possible outcomes for the second selection is 4. The number of possible outcomes for the third selection is 3, if that makes sense. Let me actually just maybe do that down a little bit. Let's actually maybe just exemplify that a little bit more, okay? So let's say, for argument's sake, okay, let's say an example, okay? An example, okay? So in our situation here, okay, let's say what we have is, let me just try to grab an example here of how this would actually work in real terms, okay? Let's say, for argument's sake, okay, so let's say we have, okay, let's think about this here, okay? So an example, okay, so let's say we have, let's say 5 objects, okay, 5 objects, okay, in a bag, okay, and 5 objects, and let's say they're different objects in the bag, okay, let's just keep that in mind, let's not complicate things at this stage. So we have 5 objects in a bag, okay, and let's say 3 selections, okay, are made from the bag, okay. And let's say without replacement, okay, without replacement, okay. And now the question is, how many possible outcomes, okay, outcomes are there? Okay. Now, I suppose, well, what we have is we have 5 objects in the bag. So in total, initially the bag contains 5 objects. Okay. We're going to make 3 selections from it. Okay, so there's going to be 3 events. There's going to be 3 trials, if that makes sense. There's going to be 3 trials. Okay, and after we perform each trial, we don't put the object back in the bag. Okay. So in this situation here, because we have, for each trial, we have a different number of objects in the bag, okay, for each trial, okay, we're going to go to counting rule number 2. Okay. So the number of possible ways, okay, that the first selection can be made is, well, we've got in total 5 objects. So the number of possible ways for the first selection is 5. Okay. Now we don't put the first object back in, so there's only 4 objects now left in the bag. So the number of possible ways for the second selection is 4. We don't put the second selection back in, so now we've reduced it by 2. Yeah, so there's only 3 objects left in the bag. So for the third selection, the number of possible selections is equal to 3. Okay, which gives us, well, 5 fours is going to be equal to 20 multiplied by 3 gives us 60. There's 60 possibilities. Okay, when it comes to those particular selections, if that makes sense. Okay. What about maybe if we have, let's say, something like, let's think about something different here, yeah. Okay, let's say we have something like, actually, well, we just leave that there. That's just an application of rule number 2. Yeah. So what we really need to move on to now is rule number 3, okay, which is really where this concept of factorial notation is coming into play for us. Okay, so let me just actually move this out right here, and let's actually have a look at rule number 3. Okay, rule number 3, the counting rule 3, counting rule 3, okay, says this, okay, the number of ways, okay, that all n items, n objects, okay, can be arranged, and we're considering these to be different and unique objects. The number of ways that all n objects can be arranged in order, okay, is n factorial, okay, which is equal to, n times n minus 1 times n minus 2 all the way down to 2 times 1 and so on and so forth. Okay, where, let's just keep in mind, where 1 factorial is equal to 1 and 0 factorial by definition is also equal to 1. Okay? So what it's saying is this, is that if we have n objects, okay, and we want to arrange them all, well, let's think about them objects being n objects in a bag. Okay, so because it's n objects in a bag, we can make n selections from the bag. Okay, so in that particular case here, now the number of ways that each one that they can all be arranged, yeah, and let's consider that we're not putting the objects back in, is, well, you can have n chances for the first one. You don't put it back in. You've n minus 1 selections now for the second one because you don't put it back in. And then you don't put it back in. You have n minus 2 selections and so on and so forth. Okay. So for example, okay, if a bag contains let's say 4 objects, okay, well then these objects can be arranged in 4 factorial ways, okay, which is 4 factorial is simply equal to 4 times 3 times 2 times 1.